Hello. Okay, so this is another live stream for a LXD release. This time it's LXD 4.12 that we released yesterday evening, and that will be hitting most users starting next week. There are quite a few new features in this release that I'll be going through. Not all of them are particularly easy for some users to play with at this stage, but yeah, there's definitely a bit of yeah, there are definitely new things for pretty much everyone. We've got features that are mostly relevant to those doing clustering projects, but also new things for virtual machines that are going to be quite interesting. So let me just switch over to a terminal. There we go. And let's look at the first feature, which is the newly introduced network ACLs. So for that, I need to switch to an environment that's got a cluster. That's a cluster with Oven, effectively, specifically. Let me actually do that properly. There we go. So this is a remote cluster. I've got 3 machines, a bunch of projects on there. I'm currently using that demo project, which runs two instances, one container, one virtual machine. And on the network side of things, they're attached to an Oven-backed network. So if we go into one of those right now and try to reach the internet, things kind of work the usual way. There's no restriction, no nothing. It's the normal LXD network at this stage. But things have been changing a bit. A lot of people with similar environments want there to be some ways of doing firewalling. And there was no good answer to that other than, go and do IP tables or NF tables directly on your router, which is still kind of the go-to way of doing it for traditional bridge network with LXD. We don't support the new ACL mechanism for those yet. But for those using Oven, the firewalling can be directly done by Oven directly at the SDN level instead of having to be done at the gateway level. So let's start by looking at the new command. So there's a new set of commands under LXD network ACL where you can create access lists, delete them, edit them, list the rules in there, rename, directly add and remove rules. So what we're going to be doing here is going to be starting by creating a default ACL. Now, as soon as you assign an ACL, it blocks any traffic that's not directly allowed. So if I was to just apply that to my default network, so apply it to all ports in that network. So I just set that. Now going here, things don't work anymore. But that's not a problem. I can go and let's say, let's edit that ACL. So get into an interactive text editor. And we want to allow to add an egress rule. So we're going to be allowing some traffic. The destination we want to allow right now is just a Google DNS servers. So and just enable the actual rule, so state enabled, and that should just work. So at that point, I'm just allowing all traffic to those 2 addresses. The rest is still blocked. Now, doing that, that doesn't just apply to egress traffic to the internet. It also applies to traffic within the network itself. So if I go back into that instance and try to ping the other one, this similarly doesn't work anymore. So let's try to fix that. So what I would do here is we allow traffic to, I'm trying to remember, like so, internal, and we enable that rule. and now this works. So what that rule did is just allowing traffic to every single internal port that we have, but nothing external. So that's a nice way to not have to allow specific subnets or any of that kind of stuff. You can actually go one step further, which is let's create well, what can we call it? I don't know. I just call it foo. So we create a new ACL called foo, which doesn't contain anything at this point. So it's completely empty. And let's apply that directly to the neck of U1. Well, actually, let's launch a new instance. It's gonna be easier if we do it that way. Gonna be more visible. So I'm just creating a new instance. Let's call it U2. All right. So U2, if 0, we're gonna be setting security ACLs to foo. Okay. So now if I go in U2, it will still behave like the others. There's no difference there. It can still ping what we're allowed to ping. But the difference is now we can use that particular tag as a label for other ACLs. So what I should be able to do now is if I go network ACL edit default, is do action nine. Let's just block access to anything going towards foo. Oops, it's not deny, it's let's do reject. Okay, so I've never actually tried this, so I'm really hoping it works. Now if I go into U1 and I ping U2, that should not have worked. Okay, let me just take a quick look. So that's slightly puzzling. Foo is not being shown as being in use. So that part's a bit confusing. It should be in use by U2. Did I mess up something there? Did not. Alright, well that's a bug. I said I never tried that particular part yet. So look into that. But the idea is that you can create ACLs kind of work in both ways. Both they work as a way of doing pure filtering, as I showed here, but they also work as a way to identify traffic. So you can add ACLs to specific NIC devices on specific instances, and then refer to that for what you allow as the source or destination of traffic. Apparently in this particular case it didn't behave. I need to look into it. It could be because I'm not using because that's within a project, or some other similar bug. We'll definitely fix that very shortly, and it should actually be fixed in LXD itself by the time anyone gets 4.12 in the stable channel. We tend to do some fixes before we push to stable. All right, so that went slightly less well than I hoped. The other feature that's kind of exciting, especially because of what it will allow in the future, is the stateful stop and stateful snapshots. So I switch back to my local machine here, and we can look at what's going on. So I've got a whole bunch of containers running, that's fine. In this case, the thing I care about is cgroup 2 here, which is a virtual machine. If we go look inside it, that VM has been running for a little while, 12 minutes. If we open my machine, we should be able to find a QEMU process for it. Yep. Exactly, there we go. Now the new feature is we can do this. It's gonna kind of look like a normal stop. It does have a few differences though. For one thing, the VM will be responding on the network up until the end of this operation, pretty much. I was trying to do that, but I've got a few too many things open here. Let me just close a bunch of those because I don't really need them. There we go. Let's see if it still pings. But I think we probably, wrong IP address. The other one is one I care about, 140. Yeah, so it's still pinging right now, even though it is being stopped. As far as what's running in the VM, until it fully stopped, nothing would have noticed that anything was going on. Where it gets interesting is that now, if I start it back up, it should not take particularly long. We'll see it ping again in a few seconds as soon as that start command completes. It definitely takes longer than a normal start command, and for good reasons. So as we can see, the VM is pinging again. It's effectively started pinging immediately as LXD start returned. And if we go back inside it, the uptime is the same as when we stopped it. So what happened there is the VM state got, so its memory effectively, got downloaded by LXD, compressed and returned to disk. Then the VM was completely stopped, QEMU was completely gone. And on startup, we uncompressed that VM state and we restore the VM the way it was. The other thing we can do with this is make a stateful snapshot. So let's do a new snapshot called demo. And you'll similarly see that while that's happening, it might take some time because we do need to dump the entire VM memory and compress it. But the VM itself is completely unimpacted. It works perfectly fine. If I had a terminal in it, I can interact with it perfectly normally. There's nothing weird going on as far as you running inside the VM. Still see its uptime is 14 minutes. The VM is actually doing some stuff, I don't know, updating some images or something, because it's one of our development VMs. Another snapshot is done. The VM never actually dropped any packet or anything while that was going on. And now if we look at the VM, we're gonna see that latest snapshot here has the stateful flag alongside it. What that means is I can now very violently stop that VM. So I'm just gonna do LXD stop-f. So now the VM is completely gone. If I start it back up the normal way, let's do that. It's gonna take a tiny while, but it's interesting to show. If I do that, it just, because I didn't stop it with stateful flag, it will not have any state whatsoever. So it's right now it's going through firmware, it's going through all that stuff again, and then booting up kind of normally. So as soon as it starts pinging, we can try and get a shell, and we'll see the uptime is back to 0. Should start pinging soon. Doesn't take that long to boot that up. So maybe it got a bit upset that I stopped it so violently. Let's see if we can get a shell inside it. Okay, it's pinging. There we go. And we've got a shell in it, and we can see 0 minute. All right. Now let's restore that snapshot. So we're gonna do cgroup 2, snapshot is called demo, and restore statefully. We see the VM got stopped. Now it takes a little while because again we need to, well in this case we need to both restore all of its disk state from that snapshot, and then we also need to unpack the state and then restore it. And now the VM is pinging again. If I go inside it and I run uptime, now the VM is back to having been run for 15 minutes. So we effectively went back in time and just restored the VM, including its exact runtime state at the time the snapshot was taken. Those features are really interesting. They allow for, so the stateful snapshot feature can be useful if you're about to do something very dangerous in your VM and your VM has a lot of in-memory states, like whether it's a database or something. You can go back in time and just restore before you did some kind of operation. You're going to upset a bunch of people on your network for sure. Like any kind of established network connection is not going to enjoy going back in time, but it still works. The stateful stop is particularly interesting if you're going to be doing maintenance, like a kernel update or other operations that require rebooting the host system, because you can do that stop, then you can bring your entire system down, do whatever you need, reboot onto a new kernel or something, and then start the instances back up, and they're just going to restore their state. If you do it fast enough, things like established SSH connections and whatnot might not even notice. Like external connections might just restore and move on. So if you're gonna be taking a system down for minutes, then that's probably gonna still need a reconnection afterwards. And those two features combined is actually the basis of what we need for live migration. So we're not doing live migration right now. It's something we're looking at doing within the next 6 months to a year's time. But that's gonna heavily be using those features. So that's pretty interesting as far as what we can do with this. I was just looking at the chat and some question around whether those features can apply to LXD containers. So far, none of the stuff I've showed, and actually nothing in that LXD release really applied to standard LXC outside of LXD. LXC itself, so just the container runtime, moves at a reasonably slow pace, and we mostly work on like bug fixes and improvements and kernel support and that kind of stuff at that layer. Whereas the bulk of our current new development are features that are much higher level and that are just done in LXD. So like all of the virtual networking stuff doesn't really apply to just low-level LXC on its own. The recent development we've done at the low-level LXC is around things like improving cgroup2 support, improving using new kernel security APIs, those kind of things. All right, so the next feature we've got is restricted certificates. So that's another one that needs a bit of context, I guess, to explain what's going on. I'm gonna switch back to my cluster. Remote switch, there we go. And there you can do LXC config trust list, which shows you what TLS certificate have been trusted to talk to that LXD instance over the network. In this case, we see I've got 2 certificates, and I actually use a third method to connect because that's cluster using canonical RBAC and Candid for authentication. So my current connection doesn't actually use either of those 2 certificates. I've got a separate LXD remote, which is used and uses that TLS certificate. So if the TLS remote I've got here uses that certificate. Now, if we look at what that certificate can see when it talks to LXD, it can see all the projects. It can see like server configuration and whatnot. It can see everything. It can even configure anything it wants. Like it can go and modify, I don't know, storage config or network config or anything. There's really, well, I should have done it with TLS, but I mean, get the idea, same thing. It can really completely mess with the server. It's the full admin on it. But we can change that. That's the new feature. So if we look at the certificates on the server and we go and edit 390, which is the one I'm currently using, there are a few changes there. There's a restricted key that we can switch to true. Once we do that, only the projects that are listed there will be allowed. So if I do that and I list the projects now, I'm gonna see nothing because I didn't list any. So I'm no longer allowed to really see anything on that machine. Like if I try to list the configuration of the server, it's completely blank at this point because I'm not trusted to see it. Now to make it slightly more interesting, we probably want to actually allow something. So let's allow the demo project. And now we see the demo project is allowed. The thing that's kind of interesting is that the privilege you're getting when you do that is restricted. So while you're allowed access to that project and you can launch instance, delete instance, do any kind of thing, you can clean storage volume, etc. You can't reconfigure the project itself. So if I wanted to edit the demo project, this is not going to be allowed. As we see, we're getting not authorized. That means that the administrator of the system can apply project restriction and then restrict some certificates to that project, and those users will never be allowed to escape those restrictions because they're not allowed to reconfigure the project. This feature can be used for quite a few interesting things because a project can be configured, and we'll see that in a tiny bit actually, can be configured to be restricted. When it's restricted, it will by default block privileged containers, it will block nesting, it will block a whole bunch of potentially harmful LXD features that you could use to get full admin on the entire system. With this feature, if you create, say, a project per user and you restrict that project and you also give it some limits to allow, well, to avoid any kind of denial of service attacks, then you can give access to specific users to those specific projects and be reasonably confident that they're not going to be able to just take over your entire system. So more of the project config we've actually done recently is now, like, somewhat part of that is if we're seeing, system with a lot of different users, a lot of different projects, there's a need for having those projects behave a bit differently. And so what we did recently is go through all of the config keys on the server and really think through whether they really need to just be global config keys or whether they should also be able to be scoped to just a project. So we've done some of that. Now I can do algorithm. So I could change the commission algorithm, default commission algorithm for all images in a project or for all backups in a project. I can also change the cache expiry for images, in this case, say 10 days. And I can configure the project to not auto-update images. Images auto-update cache. I thought that was the right key. I misremember that key's name. Let's see. There's also the interval we can change. Is the interval named that way? Yeah. Oh, it's probably auto-update cached. Yeah, there we go. Okay. So those are now project config keys that effectively override your server configuration if any is set. Same thing as I mentioned earlier. If the user is not a full admin, they don't get to modify the project, so they don't get to bypass any of those settings. All right. Next up is more project and restrictions. This time in the case of a cluster. So again, this is a cluster. You can see we've got 3 machines. Now, if I run this, it's gonna be. Is it already restricted? Shouldn't be. Let me check. Maybe I did it earlier and I forgot. It is not restricted. Okay, so there's tiny issue there. It should not have applied that unless project restrictions is enabled. Let me just make a note to go and fix that one immediately after. So the new config key for that is restricted cluster target. Okay. So I'll go and fix that. I can still show the gist of it. So say you've got, I'll actually make that project restricted now. Okay, so say you've got a restricted project. Now starting before 12, a user wanting to specifically target a server will no longer be allowed to do that. The only way they can create it is by not specifying a target. Okay, this is getting frustrating. So maybe it's another issue around the restrictions that's biting me here. Why wouldn't it be authorized? I must have missed something. Okay, let me just set that one to false and try again. Okay, so it's not the restriction as, okay. Well, that's gonna be problematic to demo then. Okay. And well, I guess I'll just explain what the feature is supposed to do, and I'll make it actually do what it's supposed to be doing. Actually, maybe there's a very simple answer to all of that weirdness. There is. Yay. Okay, so the problem is that right now my client is trying to use the default project, which is it's not allowed to use. So I need to switch to the demo project. There we go. Now let's see if things actually behave the way they should. Let me just check the state of that demo project. Okay, and we'll clear that restriction for now and set restricted. Okay. All right, so maybe everything actually works the way I want. So if I run this, right, that's working. So that's downloading the image and then creating a container called A1 on the specific cluster node called Abydos. That's working just fine. And that's as a restricted user because I'm tied to just that one project. Now, if I turn on full restrictions on the project, and I try that again, let's call it A2, and well, let's use the same machine. Now it's telling me that I'm not allowed to do it because a default restriction introduced with 4.12 prevents targeting unless it's specifically allowed. So this can be done with cluster target allow. Now if we allow that, the user can now do it. So that's just another restriction we've added because it can be problematic within a cluster if you allow restricted users to place instances exactly what they wanted. They can just create too much load on that one system or run it out of resources, even though their own project is not itself running out of resources at that point. Blocking that feature then forces LXD to do its own balancing, which should avoid a lot of those kind of problems. The one exception we've got on that is while, so if I move it back to to block, right, so while a regular user on that project is not allowed to do it, if I do it as now I need to specify the project in that case. If I do it as an administrator instead of as the user, then it allows me to do it. The reason why we bypass that particular restriction when you're doing it as an admin is so that the admin can still perform node evacuation or maintenance or rebalancing instances as they wish. So while other restrictions usually apply for any user of the project, this particular one does not, specifically so the admin can still manage the cluster. Okay, so that was a bit bumpier than expected, but the feature actually works exactly as intended. It's just that I did not switch to the right project. So I was trying to interact with a project that my user was not allowed to touch. Okay, now next feature is some more configuration options for Ceph, and we can see that. So I've got 3 storage pools in this case. If we go look at the config of, say, the SSD one, there's a new config key here. This one. Ceph RBD features, which is a comma-separated list of features that you want to see enabled on every one of your storage volumes. That effectively overrides our previous default of only having layering, so only the first one be enabled. LXD needs layering because otherwise you don't get copy on write, so you don't really get the ability to create instances or volumes from images. The others are effectively optional as far as LXD is concerned, but that can really improve your performance. The catch there being that you need to see what your systems support. So it's dependent on kernel version, possibly what got backported into your kernel, and what version of the Ceph user space tools and the Ceph daemons in your cluster you're running. So we can't just detect whatever the machine supports and use the best option because there's nothing. You wouldn't want to get in a world where you boot your system onto a new kernel, then you create one container, then you reboot it back onto the old kernel because something went wrong with that particular kernel, and now you can't use that container anymore because it got it started using RBD features that your older kernel did not support. So it's up to the user to figure out what really works best for them and what they care about in their self-config, but now they can do it. They can tell LXD what they want instead of just having LXD hardcode the most basic feature set possible. So that's just a bit of an improvement, can give quite a bit of performance boost in some environments. And the last one I'll show from the CLI is we've added support for projects in LXD in its dump and pre-seed. So here I just did a dump of my local machine, and we can see now that new section at the bottom here that shows projects with the config options for here the default project and then for a demo project. So now if you write that down to a pre-seed file and you feed that to LXD init/pre-seed, then any project that's not already defined on the system will now get created based on that. And that's it for the features I wanted to show from the command line. So if I switch back to the announcement, there we go. And I go back here. The last one we've done is the initial work on improving our documentation for REST APIs. So up until now, I can actually show that. Our API documentation for the REST API was just a markdown document here, which kind of explains the basics of the API, some of the return codes, the methods, and then lists every single endpoint along with some examples. The problem is that this is extremely tedious to maintain. Like it doesn't cover every single config key, it doesn't cover every single possible attribute. We keep forgetting to add some, we keep forgetting to change some of the headers. Like every time we add a new endpoint, we usually think of adding it to the list. That's not really an issue. But every time we add like a new field somewhere, it's much harder to remember to update it. Also, like we've had a number of cases of people reporting that our JSON is not actually valid here and there because we cannot just fix it ad hoc and we don't actually try it. So this document has become a bit of a nightmare to maintain. We're trying to change that now, and the best way to do it is really to have it be generated directly from the code so that there's no real maintenance needed as the developers add new features and add comments to those features and those fields, then it will automatically get represented in the API. So I've been working on that a bit. Effectively, it's using GoSwagger to go through the LXD code base. We've got annotations on a bunch of things, which then spit out a Swagger 2.0 spec and can then be rendered by a number of JavaScript code bases or converted to Markdown or to anything else. Here we've got an example of our Swagger spec here. So that's what's generated and stored in our repo. And here it's being loaded by a JavaScript client for it. And we can see that I've added a few endpoints already. This does not cover the entire LXD API right now. There's actually a warning telling you exactly that. But it does cover the server endpoints, for example. So if we want to look at the server config, we can expand that. We've got examples with all of the different fields and example values in there. There's some example of the errors you might be getting, what kind of attributes can be set, what parameters can be set. When updating something, similarly, it shows what you can be sending through, what that kind of looks like, and the responses, again, that you might expect from the server. It even covers some of the more verbose endpoints, like the resources API. That's rather long and detailed, so it's got examples for a lot of it. And right now we cover, so the server endpoints are mostly covered. We've got certificates handled, we've got cluster, all the cluster endpoints. Network and network ACLs are also covered. Profiles, projects. So there are a few obvious omissions there, like we don't have operations, we don't have images, and most important of all, we don't have instances yet. So I'm working on those kind of on and off, adding more and more endpoint and adding more and more comments and examples and metadata on all of the different structs that we use in our API. The current thought is that by 4.13 we should have it fully fleshed out. The good thing is that this live view just shows what's currently in the LXD Git repo. So as we land more and more of the endpoints in the coming weeks, this page will update. It doesn't really matter whether we've tagged LXD 4.13 or not. This page will just always show the latest thing. And once we're done with this, we will be updating our website to directly use that instead of just pointing to the Markdown documentation. And we'll also be getting rid of the Markdown documentation as it exists, either pointing to the website or possibly using one of the Swagger to Markdown generators to automatically generate a Markdown representation as well, so that it's included in the release tarballs and people can use that kind of the same way they were in the past. So that's pretty much it for this release of LXD 4.13. As you've seen, there's still a couple tiny rough edges around the network ACLs that we're going to be taking a look at shortly. And yeah, all of that stuff should be working fine by the time we push it to stable users. Really hoping that everyone will enjoy it. And yeah, looking forward to all of the other features we'll get to build on top of that. Like, we know that 4.13 will come with that full API documentation. 4.13 will also come with ACL support for normal LXD bridges. So the ones you would normally create on like your laptop or standalone systems. Oven was the first target we did there, because it's a different way of reasoning about firewalling. So we wanted to make sure that whatever we designed would work with it, because we know that whatever works with Oven, we can probably make work fine with Xtables and NFT that we're more familiar with, and that's easier for us to deal with. So yeah, that's it. If you've got any questions or anything, you can always drop by on the forum. If you're using the Snap and you want to try this already, it's all in the candidate channel, so you can just refresh to that. And for everyone else, you're going to be getting it likely Monday or Tuesday. And let me just take a very quick look at the comments, if there's anything else that showed up in the chat. Nope. That's it. All right. Well, thank you all, and yeah, see you around soon.